The debate about which project management methodology is best can be very confusing for a new project manager. Questions such as, is Agile better than Waterfall? Is PMP better than Prince 2? Is Agile finally dead as everyone keeps predicting? Are all questions that can make it very difficult to know where to put your attention and learning and which direction to take as a project manager. In this video, I'm going to give a very quick summary overview of each methodology, but more important than just explaining the methodology, I'm going to give some context as to why those methodologies evolved and the conditions that they arrived in, the problems they were trying to solve, because understanding not only how the methodology works, but understanding those fundamentals will not only help you learn them and understand them better, but also make you understand where to apply them. And even more importantly, understand that some of these aren't project management methodologies at all. So stick around to the end of the video and I'll guarantee that you'll not only have a better overview of what the methodologies are, but understand the scenarios in which you would apply each one. Welcome to the channel. My name's Ian, and for the last 20 years I've been delivering organisational and technology change within the financial services industry. My recent book, The Project Management Mindset, is aimed at teaching project managers the soft skills and behaviours that they need to learn that project management methodologies can't teach you. This is the third in a series of videos I've made covering the chapters in my book, and in this we're going to cover the second foundational chapter, which I title A Brief History of Change. The idea of that chapter and this video is to walk through in date chronological order a series of methodologies to detail not only what those methodologies are, but the context in which they were introduced and why they were brought in, which problems they were trying to solve. So if you want to see this video and more videos as I go through those chapters in my book, subscribe to this channel. If you have any questions on this video, feel free to leave them in the comments box below and I'll reply to them as soon as possible. So if you're a regular user of a site like LinkedIn, you'll see these kind of debates happening regularly. The Agile versus Waterfall debate, the is Agile finally dead debate. And while those can be interesting and can flesh out some new ideas, I think it highlights a key misunderstanding about project management methodologies as well as methodologies in general. So a hill I'll always die on is Agile is not a project management methodology and it was never intended to be. In fact, I would argue that Agile isn't really a methodology at all. It's a set of principles. And understanding where things like Agile came from can help you really learn them and understand how to apply them correctly in certain scenarios. And as I said in the intro of my video, understanding not only the mechanics of a methodology is important, but equally as important is understanding the context of the methodology, the environment in which it was introduced into, the problems of the time it was trying to solve. And once you can understand that context along with the mechanics of it, you learn to truly master that methodology, and more importantly, you learn to understand when to apply it and when not to apply it. So ultimately, you're not wedded to a single methodology, but you have a toolbox full of tools and you can choose which one to select for the appropriate situation. So to do this, I break methodologies into three buckets. The first of all being process improvement. And these are there to address and improve existing processes, existing ways of working, and are there to focus on continuous improvement of the way an organisation operates currently. So the second bucket is what I call product development. So how do we deliver specific products, particularly software, in an effective way that meets the end user's needs? And the third is project management. So how do we deliver high risk change in a controlled fashion? So there is also a fourth bucket that I label as change management, and that's much more to do with behavioural science, or how you get people to do things differently from how they're doing things today. But that's a whole different set of skills and behaviours, and what I consider is out of the scope of this video and of my book. So let's start with the first category, process improvement. Now, in my opinion, the modern era of change management starts with two key events in the early 1900s. First of all, the publication of the Principles of Scientific Management by Frederick Winslow Taylor in about 1911. And the second is the introduction of the Ford assembly line in about 1913. The Principles of Scientific Management marks a key shift in how we think about the general workforce. It makes an attempt to shift from all people doing all things with a general rule of thumb work to specific roles and specialisations with a focus on how to do that work really well. And the Ford assembly line really puts this specialisation into practice in a significant way a couple of years later, where a factory moves from all workers manufacturing cars individually to having a moving production line, the modern production line system, where the work is brought to individual workers for them to work on a very specific component of the car. So rather than going back and forward to get the parts of the car and assembling them, the parts are brought to them, saving time and making it much more efficient, but also meaning that people are focusing specifically on one individual task and getting really, really good at doing that, making it higher quality and faster to do, while the car is being moved along the production line. And to understand the significance of the impact that had on the industry, the estimates of the production time of a Ford Model T reduced from 12 hours per vehicle to 1.5 hours per vehicle. So that is effectively the start of mass manufacturing as we know it today. And while this revolutionised the industry, it did cause some problems both in the short term and the long term. In the short term, workers felt they were being de-skilled, so started to leave Ford for other manufacturers, which led to Ford having to incentivise pay structures in a different way, which led to even wider changes in the industry. In the long term, the model required significant amounts of storage. Having a constant flow of production meant having all the raw materials, all the upfront materials there in place, which required a large amount of storage, as well as the storage for the vehicles until they were sold. And obviously having both those sets, front and back end of storage, limits the flexibility because you front loaded your production line, meaning that you need to build that certain type of vehicle for the time that you've got left in those materials. So your flexibility of products was limited. And so around the 1950s, the Japanese started to look to try and solve these problems, to build cars more on demand and not have the large storage problems, to be able to have more flexible products by building cars to the customer's demand. So they started to look at remodeling supply chains to have the materials at the point that they were needed when they were needed it. And this developed over time into a method that was called just-in-time manufacturing, and effectively became a pull method. So people pulled the materials when they needed them, rather than a push method to say, here's the materials, go and build something. And this just-in-time manufacturing came to become what we know now as lean manufacturing, and became known as the Toyota production system, which introduced the concept of continuous improvement, of continually looking at removing waste, of removing inefficiencies within your production line while not diminishing quality. And this effectively established Japan as one of the market leaders in the automotive industry, which it still is today. And Japan, being an innovation powerhouse and manufacturing powerhouse, continued through into the 1980s when electrical goods and electrical engineering started to take front and centre in the consumer market, and led to Japan being one of the market leaders, or the market leader, in quality, affordable electrical consumer goods. And quite simply, Western businesses could not match Japan in its quality and affordability of its electrical consumer products, so were losing out huge market shares to imported Japanese goods. And this led many Western businesses, particularly American, to look towards Japan for inspiration of how they could improve that quality and affordability of their electrical consumer goods. And at this point emerges Six Sigma. Six Sigma has its origins with Motorola in around the late 1980s, early 1990s. And what makes Six Sigma quite different is it focused on a heavily statistical, analytical view of quality, so proving the quality of products through multiple repetitions and measurements. It also put an organisation-wide focus on quality and making sure that consumer value was forefront into all business operations. And a significant industrial shift for process improvement was when General Electric adopted Six Sigma as their key quality principle, under the leadership of Jack Welch, who then took the company on to be one of the market leaders, one of the largest organisations by market capital in the world, who had a significant amount of their revenue generated from manufacturing, all the way from airlines to light bulbs, and attributed Six Sigma significantly to the improvements in quality and cost savings that made them that organisation they were. And this led to Six Sigma being adopted widely by other organisations seeking to follow that example. And that marks, in my opinion, the last significant industrial shift of process improvement, which moves us on to our second bucket, product development. So alongside this, from the 1950s onwards, the field of software engineering had really started to gain momentum. And from about the 1970s, the 1980s, waterfall method had emerged as the default method of software development. And the waterfall method is really quite simple. It's just a series of sequential phases that software goes through, from analysis at the beginning, into design, into development, and into deployment, to take a life cycle of an idea into a functioning application or a functioning piece of software. And this method of working worked really well up until about the late 90s, when the architecture started to significantly change towards client server from mainframe, and the introduction of the internet enhanced that to allow much wider collaboration and communication. And this led to many organizations starting to maximize and make use of wage arbitrage. So where you had a country like India that had significant technical capability, significantly competent developers, but much lower costs of living, it then became possible to take your software development and give it to those people at a much lower cost in a remote location. And while that approach had significant benefits in terms of cost and solved one problem, it inadvertently introduced another problem, and that's one of collaboration. So while the waterfall method leans heavily on specifying the software to be built up front and doing the analysis and the technical specification for it then to be built and deployed, that specification was now being done in locations like the UK, Europe, or the US in most cases, then being shipped thousands of miles away to a team remotely in India with a language barrier, with very little communication in between. And it's important to remember that the conditions of today weren't the conditions of the late 90s, early 2000s. While the internet allowed remote collaboration, we didn't have the powerful tools that we have today, like really clear video conferencing. We also had much greater language barriers at the time, which meant that kind of remote development became very, very challenging. And effectively, what happened was we spent a lot of time specifying software and having to go into an incredible amount of detail to then not hear much on that development as it was being developed, for it then to be returned without much clarification, not functioning in a way that was expected to be functioning, which kind of created like a death loop for software development, ultimately leading to an incredible amount of frustration, a lot of burned cost and a lot of burnt time. So in the early 2000s, we saw the rise of the Agile Manifesto. And that's a very simple concept. The Agile Manifesto is effectively a series of statements, a pledge, a series of ways of working that were devised by a series of software professionals in the industry known as the Agile Alliance. And that promoted simple things like, functioning software over documentation, about more iterative development, about closer collaboration with the end users, about doing things more closely together, and moving away from the waterfall method of fully specifying documentation, almost to a legal argument level, where if you didn't include something in the specification, then you could expect it to be excluded, to a much more collaborative, communicative way of developing software in a more close fashion. And this was effectively overlaid with a methodology that already existed known as Scrum, that provided some level of oversight and governance to those ways of working without becoming overly burdensome and too cumbersome. And both of those are still in use today, and I would argue are the industry standard for software development, albeit they are heavily debated, heavily criticised, but I also think heavily effective if applied in the right mindset. And that takes us on to our last bucket, project management. And in my opinion, the introduction of modern project management starts in 1915 with the introduction of the Gantt chart by Henry Gantt himself. And if you're not familiar with what a Gantt chart is, it's effectively a visual representation, a series of bars and lines that represent the tasks and their timelines within a project. So they help visualize the sequencing, they help highlight which tasks are dependent on others, and lay it out for an easy collaborative tool to help with that sequencing. And the really important thing to understand about the Gantt chart and why it's important, why that visual sequencing is critical, particularly the dependencies, is if you think about large scale projects, things like civil engineering, construction, defense projects, they use a significant amount of resources, have high costs, use a large amount of physical materials a lot of the time. So errors and misalignments in sequencing can have significant consequences, sometimes fatal consequences. So for example, having a large amount of materials delivered on a construction site before they are needed may block you physically from performing another task. Having them arrive too late means that you might have a significant amount of labour force of people around with nothing to do but still need to be paid. So that sequencing becomes extremely important as you make it into a more physical, tangible example. If you're working in an office environment like I do, you can almost get away with it in a little way because there are very little physical implications to incorrect sequencing. It tends to come out in cost or delays in the timelines, which causes frustration. But if you think about, I have a significant part of a bridge or a significant part of an aeroplane or whatever that thing is, physically in a location or not in a location when it needs to be, that can have serious downstream consequences. And one of the first major uses of the Gantt chart that's in public record is the Hoover Dam construction project that was completed in 1935. And if you haven't read much about the Hoover Dam project as a project manager, I would look into it. It's an extremely interesting example just on sheer scale, size, but also organisation. It's such a large project that it required construction of a city purely to house its workers. And if you think about the project of building a city itself, is beyond most of our imaginations, let alone building a city as a requirement for your overall project itself. So I'd recommend having a read, but that's ultimately the first recorded real tangible example of the use of a Gantt chart in a large-scale civil engineering project. And the next notable addition to project management is the critical path method, also known as CPM. And that's effectively a method of trying to define the absolute core path of a project, so visually laying out which tasks cannot be moved without impacting the overall timeline of a project. So to give a very tangible example, if you think about building a house, there are certain tasks that have to happen in sequence. If you want to meet your ultimate timeline, you have to build the foundations, and straight after you've built the foundations, you need to build the walls, and as soon as you've built the walls, you need to build the roof, and once you've built the roof, you need to seal it. And if any of those are delayed for any reason, the overall timelines of the project will increase because they're core, they must be done in sequence. Whereas there are other tasks that aren't critical to that path, such as the order of the rooms. You know, which room you decorate first or which room you develop first does not necessarily depend or have an impact on the overall timelines of the project. It may have a dependency on other things being done, like having the weatherproofing done on the house before you can develop those. But you could choose to delay developing one single room or resequence those rooms within a project without it having an overall impact on the project timelines. And alongside this, at about the same time in the 1950s, the PERT technique, the project evaluation review technique, was developed, which essentially aimed to address the estimation issue of tasks within a project to make them more accurate. And effectively, in summary, what it does is give multiple timelines for an individual task, so ranging all the way from optimistic through to pessimistic, to what as a project team you would expect that time to take, so what you would bake into your plans, but giving that full range. And from the 1960s to the 1990s, we really see a wave of development of institutes or industry bodies to help try and professionalise project management. And probably the most notable is the Project Management Institute, the PMI, who in the 1990s released the Project Management Book of Knowledge Guide, which effectively is the go-to default guide for project management and project management techniques. And that pretty much concludes our project management bucket. And I guess the key point to that is, so what? And while I've already stated that understanding not only the mechanics of the methodology, but the context of the methodology is important. So what historical problems was it introduced to solve? I think we've covered that in a very brief way in this video summary. I do have more context in my book, but there's also a whole bunch online that you can go and do your own research if you prefer. But the more important thing is, there's another aspect to this. So over the years, I've witnessed and seen many what I call pseudo methodologies developed that I think are muddying the waters on what are actually quite a simple series of methodologies for very specific tasks. I've spent a lot of time in my career working on process improvement, and I'm a Six Sigma practitioner historically myself, and I also know a lot about lean. And early on in my practicing of Six Sigma, I saw the development of what was known as Lean Six Sigma, which for me was a misunderstanding of what the two methodologies are and an attempt to create new hype around a new methodology where there was no need for a new methodology. It became a new industry buzzword. And while the two are very similar, they come at the same approach from two very different angles and can achieve very different things. And there isn't a need, in my opinion, for a third methodology, but they created one anyway. And the question I would always ask when looking at these methodologies is, what's unique about this methodology? What is going to make it different from the many other methodologies out there? But also, what are the environmental conditions that it's trying to solve? Is there actually a problem that needs to be solved? Similar to the other methodologies we've discussed already, they all had significant environmental conditions that meant they had a need to be introduced. I've personally witnessed the frustrations of waterfall as they developed and seen the shift towards an agile way of working and understand the reasons for that. It made a lot of sense at the time. I also understand the reasons why people question agile now, and that's mainly because Collaboration across countries has improved so much since the early 2000s. The ability to jump on a conference call, to see someone, to talk things through is instantaneous now, where it wasn't back in the early 2000s. It was not as easy. Now, I don't think that invalidates Agile, but I also do see that Agile has been taken beyond its original intention and made into an industry of itself. And the ability to jump on a conference call now with someone on the other side of the world is instantaneous. The audio quality is amazing. The video quality is amazing. Language barriers have dropped significantly across those remote locations over the last 20 years. But I still think Agile has a place. When I see new methodologies pop up without what I believe is a genuine reason to exist, especially if they have a certification body sold behind them and a profitable organisation pushing the sale of them and the licensing of them, the question I always ask is, how many more methodologies do we need till we finally solve our problems? You know, I've done this for 20 years, and I've seen some things introduced, some pressures introduced, like the remote working issue, that do require different ways of working. But when it comes to project management, I doubt many of us are doing anything as significant or as challenging as the Hoover Dam that was done with just a Gantt chart from our current project management tools. And while that project wouldn't have been perfect, there would have been deaths involved within that project, albeit I would argue they were probably relevant for the time. What we're doing isn't more complex than the Hoover Dam project. It's not guaranteed, for most of us, won't be to the same scale as the Hoover Dam project. So how many more methodologies do we need before we can actually do something that we were doing in the 1930s, especially when you look at the project that was coming in under cost and under time? That's quite a significant achievement, but we still don't seem to have come on almost 100 years later and still seem to need more techniques and more methodologies to try and solve problems that we had solved back in the 1930s. And I think that poses the real question, are methodologies the answer? And I think quite clearly the answer is no.